Hi, I'm Phil Norval and this short video is about radiant heating for small businesses. I'm going to give you an introduction to what radiant heating is and how it could help your business reduce energy costs and cut carbon emissions. Before looking in detail at radiant heating, firstly we need to understand the different ways in which heat can move from one place to another. Heat transfer can happen in three main ways: conduction, convection and radiation. Traditional heating systems, which use boilers and radiators, deliver most of their heat to a room by heating the air, which in turn keeps us warm, and this is an example of convection. Although if you placed your hand on a radiator it would feel immediately warm or even painfully hot, which is due to conduction directly from the radiator to your hand. Radiation is the transfer of heat in the form of electromagnetic waves. The hotter an object is, the more radiation it emits, and this radiation can be absorbed by some objects, causing them to heat up. This is the process by which the sun's rays heat the earth, or how a campfire can keep people feeling warm even though the air temperature is below freezing. The radiation that is most useful for heating people is infrared. This is invisible to us as it lies just beyond the red part of the visible light spectrum, but because it's easily absorbed by our skin, we feel its warming effect. Radiators are probably the most recognisable type of heat emitter, and going by what we've just seen, the name would suggest that they heat rooms via radiation. In reality though, they actually do most of their heating by convection, meaning they have to heat up the air in a room before people feel warm. True radiant heaters avoid having to heat up all this air, and instead the infrared radiation they emit heats up people and objects directly, potentially from some distance away. They differ in their design from conventional convective heaters by maximising the heat they emit in the form of infrared radiation and limiting what they emit through convection or conduction. As you may imagine, removing the need to heat the air in a building can save large amounts of energy and shorten the time it takes for people to feel warm. This is especially true if the building is poorly insulated, if it's very draughty, or if doors and windows are open a lot of the time. Large spaces such as factories, warehouses, sports halls and large retail stores are particularly well suited to radiant heating. In these kinds of space, it's also possible with radiant heating to only heat certain areas where people are working, potentially making further savings possible. So that explains why radiant heating might be of interest to some businesses who want to save energy. The actual setup though will vary depending on a number of factors, such as which energy sources are available, the building's layout and the materials used to construct it, and also how the space is being used. So we'll have a look now at some of the main types of radiant heater and how they might be used. There are three main heat sources for radiant heaters: mains gas, electricity or hot water, which is sometimes referred to as hydronic radiant heating. In large buildings with high ceilings and low fire risk, gas-fired radiant tube heaters are often the most popular option. These usually take the form of a long blackened metal tube with a polished metal reflector above. Inside the tube, a gas flame is used to raise its surface temperature to a few hundred degrees Celsius. The tube's shape and colour ensure that as much of this heat as possible is emitted as infrared radiation, and the reflector surrounding the top side of the tube is used to direct as much of the radiation as possible downwards where it's of most benefit. Gas tube radiant heaters are generally used for heating a large area, but are not as well suited to a more localised use. For heating smaller areas within a larger space, a gas plaque heater may be more suitable. These take the form of a flat plate or plaque that allows a gas flame to burn evenly across its surface. The plaque heats up and emits infrared and a small amount of visible radiation. The plaque is framed by an aluminium reflector which directs the radiation to where it's needed. These heaters are much smaller and positionable than the tube heaters, so they're better suited to very localised heating of individual workstations. Electricity is usually very expensive compared with natural gas, so electric radiant heaters are normally only economical where gas isn't available or it's not safe enough for the location. Some electric radiant heaters emit a bit of visible light as well as infrared, but others, which operate at much lower temperatures, emit nearly all of their energy in the form of infrared. Because of the lower temperatures from these, though, they do need to cover a much larger surface area to deliver the same amount of heat. For that reason, the low temperature electric radiant heaters tend to take the form of flat panels, which can either be suspended from the ceiling in the same way as lighting or mounted vertically to walls. Where direct gas burning radiant heaters are not suitable, but gas is available, there is one way in which gas can still be used for radiant heating. And this is achieved by first generating the heat from gas in an ordinary boiler and then sending the heated water through a series of specially designed flat panels. These are quite similar in some ways to traditional boiler-fed radiators, but they've been optimised for radiative rather than convective heating. This means that they have a very flat surface on their front and an insulated case on the back, so that the only hot surface is their front face. This ensures that as little convection as possible is allowed to happen and as much radiation as possible is directed forwards. These heaters have a much lower temperature than the other types of radiant heater, so that makes them safer for spaces with low ceilings or combustible materials nearby. The lower temperature does, however, mean that they usually need to cover a larger area to ensure that sufficient heat is provided. Radiant heating design is often closer in its approach to designing a lighting system than a traditional heating system. Just like visible lighting, infrared radiation is emitted from its source in a beam, which as it spreads out becomes less intense with distance from the heater. Heaters therefore have to be of the right power output and spacing to ensure that at the height where people are, the radiation feels warm enough and is evenly distributed. One disadvantage of these heaters not directly warming the air is that the heat doesn't go around corners. People only benefit properly from it if they have an unobstructed view of one or more of the heaters. Because of how radiant heaters keep people warm, normal room thermostats, which measure air temperature, are not the most effective way to measure how warm it feels in a room. Instead, a device known as a black bulb thermostat can be used. This looks like a black dome which hides a temperature sensor and allows infrared radiation to pass through. The temperature sensor therefore detects how much infrared radiation is falling on it, which gives an indication of how warm it feels. In many situations, radiant heating alone is not the best way to keep a space warm. A minimum air temperature might be needed for either occupant comfort or preservation of stock, or simply to keep the building itself warm enough to avoid frost or condensation. So some spaces might benefit from a combination of convective as well as radiant heating. So as we've seen, radiant heating is particularly well suited to poorly insulated, draughty buildings with high ceilings. But the reverse of that is also true, so it's unlikely that radiant heating will reduce consumption by very much in well-insulated, airtight buildings, and low ceilings tend to prevent radiant heaters from creating a good, uniform coverage, and they can also bring the heaters too close to people or flammable materials. Radiant heaters, unlike convective systems, don't really turn up or turn down their power output. Instead, they're pretty much just either on or off. And That means that without well-adjusted thermostats and timers, it is possible to quickly overheat a space and waste a large amount of energy. Manufacturers often quote a very high saving potential from installing their radiant heating products. Independent testing and verification of these savings is not at all common though, so figures quoted by these companies should be treated with a degree of scepticism. It is reasonable though that in a large uninsulated and highly ventilated space that a radiant heating system would reduce the kilowatt hours consumption by around 10 to 25%. So despite these kilowatt hour savings, in the case where an electric radiant heating system is replacing a gas convective heating system, the savings in kilowatt hours won't necessarily translate to a cost saving, and that's because electricity is so much more expensive than gas. However, electricity being supplied through the grid is becoming rapidly less and less polluting the more fossil fuel power plants are being replaced with renewables. That does mean that although an electric radiant heating system may not have much of a cheaper cost to run, it will gradually become more of a saving in terms of greenhouse gas emissions. So I hope you found this video useful. You can find a lot more information about radiant heating by downloading our fact sheet, or if you're interested in any other energy saving technologies, we have several more videos available. And thanks very much for watching.